Okay, so we're doing chapter 33, the trig chapter in my book, Overcoming Digital SAT Math. Remember, if you have a copy of this, attempt the problems on your own first, attempt corrections on your own first for the best results, and then come back to this video for explanations as needed. So, let's go and start with number 1. So it says, for the figure above, which of the following is not true? Let me just zoom out of this a little bit. So we want what's not true. And so it's all referring to like this X as the reference angle right here. So this, because it's a right triangle, if we're thinking about SOHCAHTOA, thank you guys for liking the live. So is this one of the, hold on. Well, we could just do really quick Pythagorean theorem, or actually we don't need to, because all of the answers are just 36 over 85. So let's see, let's start with cosine. So cosine of x would be the adjacent, because it's the ka, over the hypotenuse. So that would be 36 over 85. So that is true. Remember, we're looking for what's not true. Okay, and now let's see, okay, let's look at sine of 90 minus x. 90 minus x would be the complementary angle. Whoops, that's supposed to be a 90 minus x. So that's the complementary angle, because remember, all angles in a triangle need to add up to 180 degrees. So I know that these have to add up to 90, so I could say this one's x and this one's going to be 90 minus x. So really, when I'm saying the sine of 90 minus x, I'm saying the sine of this angle, so opposite over hypotenuse, 36 over 85. So that's true. Remember, we're looking for what's not true. And then let's see, we know that 36 over 85, we just figured out, is equal to that. We know what cosine of x is, that it's also 36 over 85. So when we subtract those, we get 0, so it can't be that, because that's true. Over here, it's saying cosine of 90 minus x needs to equal 36 over 85. Remember, cosine, if we're talking about this angle right here, would be the adjacent, this side, over the hypotenuse, not the 36 side over the hypotenuse. So that is not true, so it would have to be D. Okay, let me just erase this right here so it doesn't carry over. Okay, so now let's go to number 2. For number 2, it's saying that we have triangle FGH is a right triangle, and angle H is the one that has the right angle. Angle H is 90 degrees, so let's draw that out really quick. So this will be angle H, and we could say this is F and this is G. If sine of F is equal to 0.80, then what is the value of cosine of G? So we want to find cosine of G, cosine of this angle right there. So remember, complementary angles, angles that add up to 90, this angle and this angle are complementary angles, they add up to 90. That means that the sine of one has to equal the cosine of the other. That's one of our trig identities. So if I know the sine of this angle, I also know the cosine of its complementary angle, because they're going to be equal. So it would also just be 0.80 for cosine of G. That was terrible handwriting. Sorry, my phone like blocks what I'm writing, so I just have to kind of like guess where I am on the page. But that. Okay, so let's go to number 3. Triangle FGH, so it's the same situation, it's just a different question. So we're going to draw the same triangle, where H is the 90 degree angle, and this time we want to find the tangent of G right over here. So we're looking at this as our reference angle, and remember, tangent is going to be the opposite over the adjacent, because it's the TOA in SOHCAHTOA. So it would be this side over this side right here. But they already gave us that sine of f is equal to 0.80. Now, if we think of 0.80 as a fraction, you can think of it as 8/10 and then simplify it to get 4/5. So you could also say it's equal to 4/5. And the reason I'm doing that is because it's more helpful to think of it as a fraction, because then I can say, oh, sine is opposite over hypotenuse. So that means that 4 I could think of as the opposite side for angle F, which would be right here. And then I could think of 5 as the hypotenuse. Then that just means if you've memorized your Pythagorean triples that you have a 3, 4, 5 right triangle. You could also use Pythagorean theorem to figure out that that's 3, but obviously memorizing the triples and knowing that is faster. So if I wanted to find out what is the tangent of G, I would want the opposite over the adjacent, or 3/4. Thank you guys for the likes. So let's go to number 4 now. So the given circle has a diameter FH, so this is the diameter. And assume FH is 2, so I'm going to label that with a 2. If FHG, so this angle right here, is theta. Ooh, that was a terrible theta. That's theta. Then which expression is equivalent to the area of triangle FGH in terms of theta? So remember, area of a triangle is equal to half of the base times height. Let's call this the base and the height x and y respectively over here. So we'll say that it's half of x times y would give us the area of this triangle. Now, this is a right triangle. And I know that because this is the diameter right here. So then half the diameter, that's the diameter. So it's half the circle that we're talking about over here. That corresponds to what like this, I'm trying to think of the best way to say this. This arc represents half the circle, right? So then this has to be equivalent. This angle right here has to be equivalent to half of that. So half of 180. And so that's how I know that it's a right triangle, and then I can just say that that's the base and that's the height, or that's the base, that's the height, whatever you want to do. And then now I'm going to try to figure out, okay, how could I say what x and y are so that I can plug it in and get one of these answer choices. So let's start with, I see there's sine and cosine there, so I'm going to start with sine of theta. Remember, sine is going to be the opposite over the hypotenuse, so it's going to be x over 2. So then if I want to get x by itself, because that's what's most helpful for me, I'm going to multiply each side by 2, so then I'm going to have 2 sine of theta is equal to x. Now I'm going to use similar logic to go and find cosine of theta, because that's also in some of the answer choices. So I'm going to go and say cosine of theta is the ka part in SOHCAHTOA, so it's the adjacent over the hypotenuse. So adjacent y over the hypotenuse 2, so is equal to y over 2. Now I'm going to multiply each side by 2 so I can get y by itself to plug in here. So then it's going to be 2 cosine of theta, is equal to y. So now I know what y is, I know what x is. I could just plug them in here to figure out what the area could be equal to. So it's going to be half of 2 sine theta times 2 cosine theta. Now half and half times 2 is just going to cancel out to 1. So then we're just left with sine of theta times 2 cosine of theta, which is just 2 sine theta cosine theta. So that would be A. Thank you guys for the likes. Please share this with anyone who needs help with trig stuff or SAT, ACT prep stuff. Let me just erase this. Okay, so let me just make sure it's not, okay, there it's clear. Okay, so we're gonna use this, this figure for the next couple questions. Now, I put a reminder here because this is a digital SAT workbook that they don't do like multi-part questions like that anymore like they used to on the paper exam. So each of these would be like something you might see on an exam as its own question. I just put it together to save paper in case you wanted to print it. So we're going to find out what is the cosecant of A. So remember, cosecant is just going to be, I like to remember it as like the cosecant and secant are like the opposite of what you would think as the reciprocal. So it's 1 over the sine of A, because you would think it starts with C, it would be 1 over cosine of A. So it's like the opposite of what you would think. Maybe that'll help someone. That's just how I remember it. So I'm doing 1 over sine of A. So if this is angle A, right over here. Remember, sine is the SO in SOHCAHTOA, so it's going to be opposite over the hypotenuse. So opposite 12 over the hypotenuse 15. So sine of A equals 12 over 15. So if I want the reciprocal, I just flip it upside down to be 15 over 12, and then I have to simplify it by dividing by 3 on top and bottom. Whoa, that's supposed to be 3. And then that's going to give me 5/4 as my answer there. Let me just erase that. And then now we're going to go and we're going to do the secant of A. So again, like I do it as the reciprocal is the opposite of what you would think when I remember it. So it would be that secant is equal to 1 over the cosine of A. And then, so I'm looking at the same reference angle, A, right up here. And then I want to figure out, okay, what is cosine of A? So I could take the reciprocal of that. So remember, cosine is the ca in SOHCAHTOA, so adjacent over the hypotenuse. So it's going to be 9 as the adjacent over 15. So I just have to flip that to be 15 over 9. And then simplify by dividing by 3 on top and bottom. And that's going to give me 5/3 as my answer. So now I want to find cotangent of A. So same reference angle. Now cotangent of A is 1 over the tangent of A. So I just need to figure out what's the tangent of A and then flip it upside down basically. So tangent of A is going to be, it's the TOA in SOHCAHTOA, so it's going to be the opposite, 12, I almost said 2, 12, over the adjacent 9. So then we're going to have to flip that upside down for cotangent. So then it's going to be 9 over 12, then simplify it by dividing by 3 on top and bottom, and then that's going to give me 3/4 as my answer. And then now we have a different reference angle. We're trying to find out what is the sine of C. So let me just erase this really quick. So this is our reference angle now that we're doing, and we want to figure out the sine of C. So remember, sine is the opposite over the hypotenuse, and you'll notice we're missing a lot of information here. Now hold on, let me think if there's a easier way to do this. Then I'm thinking like right away I would think, okay, I could set up a proportion because like similar triangles, side lengths are proportional. I could do like 12 is to 15, like 12 over 15 is equal to what 9 over 9 plus, and I could call this x's, 9 plus x's. But let me see if there's a faster, more efficient way when I look at this. So I'm finding, what did it say? It was the sine of C, so that would be opposite over hypotenuse. Okay, so let's think. Yes, there is an easier way to do this. Okay, they're similar triangles, so that means that these angles are equal, so I don't have to do the whole like solving for the missing parts. I can just say, okay, the sine of this is going to equal the sine of this since they're similar triangles. So I'm just going to find the sine of E, because it's equal to the sine of C. And I know that the sine of E is equal to the opposites, which is going to be 9 over the hypotenuse, which is going to be 15 there. Then I can just simplify by dividing by 3 on top and bottom, so then that's going to be 3/5 as my answer. But you could do the other way too, it's just going to be annoying. So let's go to number 9 now. So we have, in the figure above, x is in degrees. If tan x is equal to 0.75, then what is the length of FH? So we're trying to find this guy. I'll call it this guy y right here, since we already have x right there. Okay, so first thing I'm going to do is turn this decimal into a fraction. So I know that 0.75 as a fraction is just 3/4. And then what that's going to allow me to do is I know tangent is like the TOA and SOHCAHTOA, so this has to be equal to the opposite over the adjacent. So let me see, hold on. So tan of x, so that's going to be the opposite over the adjacent. So then that means 7 over y. Yeah, that's opposite over adjacent, yes. Has to equal 3/4. So then I just have to cross, is it called cross multiply? Yeah, cross multiply. 4 times 7 and 3 times y and set them equal to each other. So 4 times 7 is going to be 28, and then 3 times y is 3y. So then I have to divide by 3 on each side to get y by itself, because that's what I'm solving for. So then I get 28/3 is equal to y. Let me get water really quick, guys. Okay. So now we have number 10, and it's saying if n is between 0 and 90 degrees for the given equation, what is the value of n? Okay, so remember, they love testing on like both the SAT and ACT. There's like a couple trig identities that they like really love to test, and one of them happens to be like sine of one complementary angle equals the cosine of the other, and that's what's being tested here. Like the sine of one complementary angle equals the sine of another, so meaning that like these angles have to add up to 90 degrees. So this has to be 40 plus 2n plus 40 plus 2n plus 10 has to equal 90 degrees. I just realized I should have probably said, oh no, it says n is between 0 and 90 degrees, so that's fine, that's not a typo. I was thinking it like said if I should say inclusive, but no, it's fine. Sorry, I went off on a tangent there. So then 2n plus, and then I'm going to combine 40 and 10, that's 50. And then that equals 90. So now remember, I'm solving for n, so I have to get it by itself, so I have to subtract 50 from each side. So that's going to be 2n is equal to 40, divide by 2 on each side, and we get, to get n by itself, and we get n is equal to 20. So that's the answer, 20. Okay, number 11. Assume that tan x equals a negative value and x is the angle measure in radians, which of the following could be true. So let's visualize this in terms of quadrants. So remember, if you learned your, like the unit circle thing that they have you memorize, that this is 0, this is pi over 2, this is pi, like if we're thinking in radians, and then this is 3 pi over 2. And then this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4 right over there. So when it's saying, like, for instance, with number 2, that the angle x has to be between pi over 2 and pi, it's talking about like, oh, it has to be in quadrant 2 right here. That's what that means. So tan of x has to be a negative value. So tan of x is negative. Now that means, since tangent is also can be thought of as like sine over cosine, that means that one has to be positive and one has to be negative in order for you to get a negative value. So that means that you need to be in a quadrant where one of the axes, or one axis is negative and one axis is positive, because we're supposed to think of, like, if we're thinking in terms of like how you're used to graphing things, kind of think of y, like how you would look at the y-axis as your sine and the x-axis as your cosine. So if tangent is equal to sine over cosine, then that means that one of these needs to be negative for the whole thing to be negative. So if this is your y-axis, this is your x-axis, think, okay, well, it's both positive right here in quadrant 1, so it can't be that one. Over here, you have a negative x, and you could have a positive y, so it could work in quadrant 2. In quadrant 3, they would both be negative because you have the negative portion of the x-axis and negative portion of the y-axis, so that does not work. And then over here, you would have a negative and a positive, so then that could work. So then it could be in quadrant 2 or quadrant 4. So 1 definitely works because we just figured that out. Quadrant 2 works as well. Now quadrant 3 would be right over here, or not quadrant 3, Roman numeral 3, which also happens to be quadrant 3, is right over here because it's between the pi and the 3 pi over 2. That does not work, we figured out. So it can only be 1 and 2, which would be C. Correct, Allie. So, point out the side length trick. I put a little note to myself to remember. Okay, so, right triangle PQR, this is how they're, formatting the question. It's more like this for the digital exam. Like, I included a couple of, like, variation questions, but, like different ways to ask trig questions to kind of, like, get you prepped for, like, all things that you could see on the exam. But this is a type of question that's really showing up a lot. So the right triangle PQR is similar to right triangle STU, where P corresponds to S and Q corresponds to T. So what I said here about the side lengths trick, just be careful when you're labeling this, because I'll show you what I mean in a second. So I'm going to draw PQR, right? So I'm going to say that that's my right angle, and then let's say that this is PQ right here. Now the reason I drew it like that is because I see, oh, RP right there, that's the biggest side length out of these. Like, that's the biggest number between 40, 32, and 24. So that has to be the biggest side. So that has to be the hypotenuse right there. So this has to be 40. You couldn't have drawn it where, you couldn't have drawn it like this, maybe. It's like hard to think how to draw it wrong because I just see it how to do it the right way. So let's think like R, I don't know, P right there, and then Q. You couldn't draw it like that because then the longest side would be one of the legs. Like, the longest side of a right triangle always has to be the hypotenuse. So this wouldn't work. That's what I meant about be careful about, like, the side lengths with how you draw it here. So, let's see. That's going to be 40, and then QR is going to be 32, and then PQ is going to be 24. So now we know that these are similar triangles. They're both right triangles. So now we're going to draw STU. Now remember, it said that P corresponds to S. So that means in where the same location of where P is on this triangle has to match up with the location of S on this similar triangle. So that's why I'm putting them both there. And then Q corresponds to T, so where Q is, T should be on the other triangle. And then we just are left with, obviously, U. So we want to find tangent of S, so the tangent of this angle. Now, again, they're similar triangles, so if S corresponds to P, that means that their tangents should also be equal. So if I find out the tangent of P, I know the tangent of S because they're the same thing. So let's do that. Tangent of P equals tangent of S. And I know that the tangent of P is going to be the opposite over the adjacent. So opposite 32 over the adjacent 24. Then I'm going to simplify by dividing by 8 on top and bottom. So then I'm going to get 4/3 as my answer there. And I think that was the last one for the trig stuff.